Yes.
Okay.
There are only few participants today. What should we do? Should we start or wait?
We'll wait for another 5 minutes, Aman.
Okay.
Good evening, everybody, and welcome back. Good evening, Aman. There are few participants. They'll be joining, so I think we can start the session.
Okay,
Yeah.
so
Your
yesterday,
screen is visible, Aman.
okay, so yesterday, we learned about clustering, types of clusterings, use of clustering in its applications in bioinformatics, clustering using Python, the code structure, which is very common for all of the codes, then important libraries and the models we will be reading. Today we yesterday we used NumPy, Pandas, sklearn preprocessing dot cluster dot preprocessing standard scalar. Today we will be learning we will be using this k-means class, then zeroed samples and zeroed score libraries classes. So for now, we will move towards what is k-means algorithm. The k-means algorithms is an iterative algorithm that aims to partition a dataset into the k clusters. K means the n number of clusters. It starts by randomly selecting the centroids. It starts by randomly selecting the k centroids, representative points, and assign each data point to the nearest centroid. Then it recalculates the centroid based on the mean data points assigned to each cluster. This process is repeated until the convergence where no are uh, centroids are no longer changed significantly. First of all, there is group of a data. Then in group of the data, there are then there are some centroids are the sign assigned. These centroids are nothing but the point values, but the center values towards towards which the another values should be converged. They form a group. The they form the group beside that specific point, that is called as centroid. How it works is that how it works is that there is the Euclidean distance formula, which recalculates these centroids, which recalculates the centroid each times. Before moving towards the programming, first we will know about Szilard score. Szilard score is used. Uh, Szilard score is the measure of how well each data point fits into its assigned clusters. It ranges from -1 to 1, where higher value indicates a better fit. The average Szilard score across all the data points provide all the measures of the quality of the quality of the clustering. Silhouette analysis can be used to study the separation distance between the resulting clusters. The silhouette plot displays the measure of how close each point in one cluster uh, is to the points in the neighboring clusters, and this provides a way to assess the parameters like numbers of the clusters visually. Um, as we seen that it ranges from -1 to 1. This is the specific this is the specific score. This is the specific range. Select coefficients near +1 indicates that the sample is far away from the neighboring cluster, and the value 0 indicates that the sample is on or very is on the boundary or very close to the decision boundary between the two neighboring clusters, and the negative values indicate that this sample this those samples might have been assigned to the wrong clusters. Means which in simple way we can say that the the silhouette score near to the one is is the ideal is the ideal score. So again, so now again today we will be seeing these important libraries and the modules, and now we will move towards the programming part.
Aman, you're there?
Yes, I'm there. I'm just switching the tabs.
Okay.
So I think my screen is visible.
Yes, Aman.
Okay, so we will start here. So first of all, we will see our basic requirement, most basic step, that is importing the libraries. We will import here the our necessary libraries for the data manipulation, visualization, and the clustering analysis. So, first of all, our libraries we will be installing here NumPy, Pandas, and Seaborn. So we will here import NumPy as in P. Next code we will be importing here the Seaborn library, which is used for the visualization purposes. Now we will import the data same uh, we used yesterday. The same procedure we will be use uh, as this data is stored in clouds and gets removed continuously. We have to import this data ahead ahead of uh, ahead of the programming. Again, we will now hear from here. We will copy the path to read the CSV file. We will here create a variable which will read this CSV file and which will contain all the data from the CSV file. using this pd dot read underscore csv. We will be importing this. We will be importing our data into the pandas data frame. Here we have copied the path, and we will be executing here now. This our entire data from the CSV file is stored in this data variable. Then what we have stored data dot, we will see this data. Here we can see the data uh, which uh, which we have which we have to work on. Now again we will be for our easier use, for identifying the columns here we will rename them. It is the part of the data pre-processing. So here I will just now copy copy the code from yesterday's. Yesterday it took me very long to write, so I just edited in it later, and we will be now using the same code here. Now we will see if the data is okay. We can set the data. We can the data is renamed. All the columns in this CSV file are renamed. Okay then. So we will now go go forward towards it. If this data dot head, this this command shows the first five entries of the data, and if we write data dot tell, it will give the entries which will be of the last five entries from the data. If we need if we need the statistical we if we need the statistical components like the data count, the mean of the data, the standard deviation, median, etc. So we will here write data dot describe. So here we can see that all the statistical components of the data, like count, mean, standard deviation, minim minimum values, maximum values, the with the similar values 20 to the 25% values, 50% similar values, 75% similar values, etc. We can share in this code. It it is very useful in the data analysis. After that, we will here move towards our main part, that is k-means clustering here. Here k-means clustering actually starts. So we will again here import the necessary libraries. import k-means from sklearn dot clusters. Import k-means. We will run now this. Make sure that the k means in k and m are capital. As the Python is case sensitive language, it will show an error. Now just now we will move towards the feature selection process. So today we will take the let us take we will perform the clustering on the subject accession variable. That is which that is which that is which data that is the which in this which column which contains in that column in the subject accession variable version column it it contains the list of the similar sequences to which the our query sequence is aligned. So for the spatial or for our feature selection we will write here data, here the name of our column, let me check here what error is there. Okay, here there was a spacing problem there. Okay, now towards the next point. This command help us. This command help us for our future selection process to which uh, to which uh, to which to which hello to which our data on which our data is to be to be worked on. This provides this code also this code also this this code also convert one of the categorical column that is the subject accession variable column. This column it will turn these entries into the numerical codes which represents the similarity to the which will represent the similarity uh, to the first to our first column. So now we will see if it is if it has converted into into the numerical codes or not. So we will again here write data dot head. We can see that this subject accession variable version column turned into the has been turned into the numerical codes. So we will here now we will here the now we will here perform the clustering analysis. This so here this part this in this section we select the relevant features for our clustering analysis. We exclude the first column that is query accession version as it is not required for the clustering. Here we can see the first entry is written here. So now we will move towards the next, that is uh, for for the k-means algorithm. We will be we will be now importing like another libraries which will be used to analyze the silhouette score and plotting and the plotting. Here, we have standardized the selected features using the standard scalar function to ensure that all the features we have selected have the same scale. Here, here from 2 to 10, here from 2 to 10, these are nothing. But the number of the clusters we will be required, and these are not the number. These are the titles. These are the name of the clusters. That is n cluster is equal to 2. It will be our first cluster. N cluster is equal to 3. It will be our second cluster in the number. These are nothing but the name of the clusters we will be assigning. We can make how many clusters we can decide on our own how many clusters we will be needed. uh, or to be specific, or to be specific, how much cluster can be formed, and which and can be and how many, and that RB efficient. There is another method which is somewhat more more lengthy. uh, so which is somewhat more lengthy. It is called as elbow method. It is called as a elbow method, which decides the number of the clusters. It is a separate algorithm. So we will be here. This will be our name of the clusters for, and now we will be moving towards the clustering part. So here uh, in the in this section we will be creating a subplot with the first row, with one row and two columns. So then now, the first subplot, uh, there there will be the first subplot will be of the silhouette plot. and the second subplot will be from the of the coefficient. Uh,
Hello, Aman.
Yes.
Uh, Wanted to make sure if you're speaking or not because your audio is not.
Okay. Actually, the code is too long for this, so it is taking much time.
Okay, okay, no problem. Yeah, please continue. Thank you.
Okay.
Participants, I have shared the feedback link on the chat, so please take your time and please fill the feedback form. If you have any questions, you can post it in the chat as well because we're running out of time. So if you have any questions, Aman will take up to answer them. So if you have any questions, please do post in the chat. You can also unmute yourself if you can't type.
So, guys, that's we can say the time is running out. I have performed this code already. Once more, I will just show it you here. Please just wait for a minute.
Aman, you stopped the screen sharing?
Yes, just a second. Just when
Okay,
it was we just switching the tabs. So,
okay.
so this is actually the full code. We didn't we the session took the longer than I expected. So I will here just I will just here explain this code. So this part is this part is mainly consist of the clustering and the visualization process. So here, so first of all, here where we here in this section in this section we have created a figure which will be containing the two subplots for the visualization process. Then in this section in this section we have uh, in this section we have we we have set the limits for the x and y axis for x and y axis limits. Here we have created the clusters, and here for each cluster we the random it will be it will be taken randomly. Then here for the select value, the select value it will be for the validity it will be for the validity of the validity of the clusters we have formed. This is all for the select this code. This code it shows it shows the select score for the samples belonging to the cluster I. That cluster I will be the name of the clusters. The this section xl1 dot fill underscore between. Here we plot the select score for each sample belonging to the particular cluster using the fill uh, underscore between x function. Then this part this is x2 dot scatter. This In this section we will be creating the scatter plot to visualize the actual cluster formed based on the selected features. Um, this this all will be the this all will be the features of the this all be the uh, features of the clusters we formed, and as well, and these will be the features. X2 will be will be the will be the feature of the scatter plot, where we will find how the clusters are actually formed, and it will be and it will be shown on the form of on the graph how many clusters are formed and how the clusters are formed. So now we will execute it. Looks like as I have taken the different set of variables here, so we will just represent here as capital. From here we can see that for cluster for n cluster is equal to 1, it will be our first cluster. Its reload score is 0.60 uh, 34, which is not near to 1. So we can say that the cluster formed is not the sample belonging in the cluster is not as much as close to the centroid value. Here we can see that as we go down, the sealed score goes near to the 1, which shows the validity of the clusters. And here and in this second plot, um, we can see the visualization of the cluster data, how the how the clusters are formed using the data. These are the numbers of the clusters we have assigned. So guys, that was all for today. If any query, you can leave in the comment box or can ask me directly.
Participants, we have come to the end of the session. If you have any queries, please put it in the chat box.
I hope there
So,
are no queries.
yeah, we don't have any questions. Right, but then we will end the meeting. Thank you so much, Aman, for sharing your knowledge. And I thank all the participants for joining us for the 2 days workshop on clustering using Python. I request everybody to please fill the feedback form, and you all will be receiving the certificates and the recordings by Monday. Thank you so much.